All right. Welcome to welcome to my stream. This is a new stream and I'm going to continue with building my um web browser version of the Suika game. So last stream where we left off, I finished the tutorial to generate a floating box with the Firefox logo. And this is a WebGL tutorial. I'm gonna continue on with the tutorial. It seems like I might be able to finish it with these last two sections. So if you haven't tuned in before, I am creating this web browser game using WebGL and JavaScript. I am wrapping it around a Node.js web framework called Express, and I am version controlling everything using HG or Mercurial. So in order to load up JavaScript files from local HTML files, we need to wrap it around a web server. So I'm doing that by using the Express web framework. So to start it up, and I just have it running as I'm updating the files, which is refreshed immediately as soon as I reload the browser. But so to start up the web server, I navigate to the project directory and then I do npm start. And it's a bare bones web application. The only stuff that's interesting in this otherwise stock project is just all in the public directory. I have game.html, which is the HTML file, and it's pretty basic. The only interesting parts in this file are the calls to the JavaScript files, geomatrix and game.js, as well as a canvas, which is where the game will reside in. So the bulk of everything is in the JavaScript files, which I've been editing from the tutorial. And the two file, so geomatrix is just a third-party open source library used for manipulating WebGL stuff. But the bulk of the logic is in game.js and modules.js. Game.js is where everything ultimately goes, but module.js has a lot of the stuff that game.js uses, specifically the init buffers and the draw. So let's continue on. Let me show so far what I have. So far, we got this. So I'm using a Windows machine and Chrome just because that was what I had lying around. And Chrome is a very convenient web browser to use for code development when it comes to web browser stuff. They have the web developer tools. I think that's what it's called, which is really useful in troubleshooting or seeing what's going on. All right, so now we will continue with the next section of this tutorial. And I have no experience with WebGL apart from this project, which I had tried to stream from beginning to till now. The first two streams didn't work out. The first stream was not recorded at all. The second stream was just a blank screen, which isn't very interesting to watch. So really, my previous stream was my first real stream that where everything seems to have gone well, and but I was kind of halfway through this entire tutorial by then. But anyways, so we'll just continue. together and learn together. It just runs two functions. WebGL doesn't have much built-in knowledge. Two functions. Okay, so I have a vertex shader and a fragment shader. Yeah, so something interesting from the previous stream is that the tutorial actually didn't work, and I had to do some troubleshooting to update the code so that it to get it to work. Creative functions to get the result. In other words, if you want lighting, you have to calculate it yourself. So this is interesting also. So in the Suika game, let me pull up a screenshot. So the in the Suika game, the graphics don't seem to be very complicated. It's basically just dropping balls on top of each other, and when two of the same touch, they combine to form a bigger ball. So the graphics doesn't seem to be very complicated. What I'm considering though is the logic or the physics rather of how the objects interact with each other. That seems to be something that will be more challenging, and I'm considering whether to look for a third-party JavaScript library where someone's already built, or to write it myself from scratch. And I'm gonna go with my options from easiest to hardest. I'm gonna look for third-party libraries first, and if I find a suitable one, I'll just use that one. If I can't find a suitable one, then I will write my own and together with you all who watch my stream. Okay, so this tutorial is simulating lighting and shading. Simulated light 3D fong shading. So fong shading. Okay, interesting. Hmm. Yeah, 3D computer graphics. This was something that my dad. That's how my dad started his career as a computer programming. Was working on 3D graphics. So it's interesting how. But for me, I've been a web developer, which is a software programmer as well. For my entire career thus far, which has been 13 years, well, 12 and a half. And I have never had to do 3D computer graphics. 3D. So this is interesting. So that's interesting reading a little bit about the Feng shading. Three types of lighting. Ambient light, ambient permeates the scene, affects every face in the scene equally. Directional is from a lighting source, so it comes from far away. Okay, so it's like a parallel light. So like all the objects are affected in the same point light is one that's from a point. And so like seems like that's the most complicated form of light where everything is like all the surfaces that you see are gonna have to calculate um calculate the light. Okay, okay. So yeah. So this tutorial will ignore the point light. Obviously, or at least to me, it seems like that is the most intensive. It'll require the most resources to calculate, and it'll be the most complicated. So ignoring that should make things a lot. It should simplify things a lot. Ambient direction drop out constant point sources directional line associated surface normal perpendicular to the face surface normal direction vector. So we need to know, where the light is coming from, the direction, and then we also need to kind of like if you have a surface um an arrow pointing out directly out of that surface, that's the surface normal. To adjust the color. Oh, adjusting the color of each depending on the lighting. Normals for these. So also interesting is that the Suika game uses sphere. So it's the way that lighting is. And I might just ignore the lighting um for now because yeah, because when I see the game as it is, it doesn't seem like there's much going on with any specific special lighting. Seems to be very independent of the lighting, and can just make a fun game even without fancy lighting. But I'm still gonna follow this tutorial. Okay, so it says, uh, so I'm gonna add to the init buffers file, which is my modules file. So I have so far init buffers, init color buffer, init texture buffer, init position buffer, init index buffer, and now we're gonna add a init normal buffer for the normal vertex or vertex normal. I'll add it after the position. Yeah, after the position. So I'm recognizing patterns. It seems that for all of these buffers, they all start with create buffer, gl.create buffer, and then bind buffer. So yeah, sometimes they're array buffers, sometimes they're element array buffer. Hmm. this is the front face of the um square. Now I'm trying to make sense of these numbers. So okay, I think I got it. So the front face is composed of four vertices, and these are the XYZ coordinates for each of the for the normals of each of these vertices. And so we see, so if we do that, we get XYZ. So X is 0, Y is 0, Z is 1. So it's, so for the first vertex on this face, it is pointing directly at the out of the screen. And same goes with basically all the vertices for this face, which makes sense. As the front face would be the face of the cube that's facing us, facing the viewer. Yeah, and then back makes sense that it would be the front, except with the Z pointing um, in the opposite direction, so -1. So knowing that, I'm just gonna copy and paste and then negate the Z-axis. Now the top face, it seems like that would be XY. If we do XYZ again, it's just setting the Y axis to 1, so pointing directly up for each of the vertices in that face. And then bottom would be uh, the opposite of the top. So yeah, never mind. Okay, and then right and left is setting the x-axis to 1. Just in opposite directions. Okay, so vertex and then gl dot bind buffer data. All right, and then at the end of the init buffers, gonna add a normal, which calls the function that I just wrote, or copied rather. Texture record normal. normal buffer. Next, add the adding to the draw scene.js, which is also in the same file. I combine these two files together. So we're gonna add a set normal attribute. And I have other set blank attributes such as set position attribute, set color attribute, set texture attribute. So I'll put it after the set position attribute. And then add a call to this function in the draw scene. So it says before the gl.use program. So that would be before this gl.use program. I'm gonna put it after the position set position attribute. And then update the code that builds these matrices to generate and deliver the shader a normal to the shader normal matrix. Transform the normals when dealing with the current orientation in relation to the light source. All right. After the three mat.rotate. So the mat.rotate lines, they are responsible for rotating the box in all three axes, albeit at a different rate for each of these axes. So this is Z, this is Y, this is X. And then it says to add this mat4.create. Mat4.create. Okay, so I had to do a mat4.create for the projection matrix. So I'm doing it now for the normal matrix. Now I transpose normal. Okay. Uniform matrix FV. After that, I should do a Okay, so instead of the projection matrix, the model view matrix, now I'm doing the same thing with the but with the normal. So then let me check to see if it's consistent with so I saw the projection matrix with the map for create. What about the um other one, model view? Okay, so the model view matrix also had a similar thing. Interesting. It doesn't make sense. I don't understand what it's doing specifically, but I recognize that it's consistent. It's a consistent. It's a pattern. I'm recognizing a pattern. Update the shaders. Okay. So shaders, I think they're in the game.js. Yes, vertex shader and fragment shader. Wow. So adding a lot more to the vertex shader. So yeah, so from the previous tutorial, I had to convert this tutorial, which it seems like it's using a older version of WebGL, and I had to update it to a newer version, so version 300 ES. So some of these will look different. So I'm gonna try to just uh, on the fly convert them in my head and type them out. Uniform text model and then projection. Varying. So there was texture three. Ooh, rating. Hmm. Wow. So the main got a lot more complex lighting. So it seems like there's low P, medium P, and high P. Precision, I'm assuming that's what P stands. And I suppose that's determining how many digits to calculate before giving up, or like how many digits to calculate. There's no giving up. So we're just setting um, the various light sources. The It seems that ambient light is gonna be a dim gray or dim light. So it's like white would be 111, which is the directional light color, and then 000 is um, blackness, completely dark. So zero point 0.3 for the ambient light is closer to dark than light, but there's still something there. right? Max. Huh, is that right? Oh, gotcha. So if it's ever negative, it's just gonna default to 0. Um, for the directional. That's what the max dot stuff is doing. Line. Okay. All right, so let's go through this description. I feel like it's going to be really helpful. So once the position of the vertex is computed and we pass the coordinates of the text cell. So that the text cell is the pixel at a specific point. Text cell corresponding to the vertex. Of course, the coordinates of the text cell corresponding to the vertex to the fragment shader can work on computing the shading for the vertex. The first thing to do is transform the normal based on the current orientation of the cube by multiplying the vertex's normal by the normal vertex. Vertex is normal. We can then compute the amount of directional lighting vertex by calculating the dot product. Oh wow, dot product. So the dot product, that's a matrix operation. I forgot specifically what it is, but it's multiplying two matrices together. College stuff you learn in college and then forget later on. Transform normal. Transform normal in the directional vector. If the value is less than 0, then it's 0. Can have less than 0 light. That's interesting. Once the amount of directional lighting is computed, generate the lighting value by taking ambient light. Okay, so then it's the ambient light is just a offset, the DC offset. So basically, the calculation is just for directional lighting, and then the ambient lighting is just you just add a offset. You add a constant to it to get the final lighting. So I'm wondering. So my guess is that the V lighting would be a factor that you multiply to the RGB value to get the light, the total lighting. And this V lighting is dependent on that vertex normal and the values for the ambient and directional. Okay, so now we update the fragment shader. Oh, need a okay. So we so this V lighting is from the uh from the vertex shader. V lighting. So the vertex shader calculates the V texture chord and the V lighting, and then the fragment shader continues the processing. IP spec uniform sampler 2D sampler. Brad color. Yeah, so you can see these minor differences. These are the things that are actually needed, and they were from this tutorial. Spec for text cell color. So it seems like I'm gonna have to do define this as well. Text cell color 2D. Oh no, I don't. So see the similarity. Previously I had texture, now I have texture 2D. And then the frag color is gonna be um, cell color RGB times B lighting. There's the factor that I was talking about, and then that's the alpha is the opacity, and we have it set. It's just 100% opaque throughout the tutorials. It would be interesting to see what happens when it's not opaque. Okay, here we fetch the color of the text cell. We multiply the color by the lighting value to adjust the text cell's color. All right, look up the location of the vertex normal. Vertex position, vertex normal. Uniform location, projection, model view, use sampler, matrix. That's it. All right, let's check it out. Ooh, that's interesting. Okay, I saved the files. Let's see if we have any issues. Ah, we do. All right. Texture 2D, no matching overloaded function. Okay. Texture 2D. What's wrong with texture 2D? So that is here. I'm gonna try this. So we originally had texture. I'm gonna try it. Well, I guess that worked. Interesting. Yeah, so it's interesting that yeah. So the um faces, they all have one color, and that depends on what direction they're facing. Cool. Pretty cool. All right. Per pixel lighting. Okay, yeah. So each face has four vertices. And so right now, this tutorial is calculating the lighting of the entire face just based on these 4 points. So in more advanced graphics, we do something that's per pixel light. Hmm. Yeah, it sounds like it'll be a lot more complicated. Okay, you might also try experimenting with the direction of the light source, the colors of the light source, and so forth. Yeah, I have a pretty good guess what it's gonna do, but we could just try it. Just try it. Just try it. Okay, so let's see. So if this was RGB, let's just make this a lot more reddish. Directional light. Let's do yeah. So it's gonna be a lot more reddish. Yeah, there we go. Mm, yeah, and then so we can make it more trippy if we. So how about ambient light? That would just be the red background. So we got a red background, and then we're shining onto this box a blue light. Let's try that. See how that. Yeah, interesting. All right. The other things we could change. Um, okay, so interesting. It's hard coding the where the directional light is coming from. So it seems like it's coming from. So this is XYZ coordinates. So we can make the light. Let's see if it comes directly from above. That should be 100. Yeah. So now the light is coming directly from above. Hmm. Believable? Kinda, yeah. How about let's change the light to be coming directly. So we're the light. We're shining onto the box. Yeah. Yeah. So it's not very realistic. Uh, like not very realistic. But if you imagine, so when the face is not facing us, but like tilted at an angle, the more tilted it is, the darker the face gets. All right, let's change it all back to the default. 0.85.8.7. Blah, 0. It was all ones. The ambient light is a darker, is a gray. Okay, so another way to think about this is that the darkest that the box will be is zero point 0.3, so 30% the brightness, and the brightest that the box will be is 100% bright. And that's all dependent on the orientation of the faces. Okay, let's move on to the next and final animating textures, replacing the static textures with the frames of an MP4 video file. Ooh, this is interesting. Hmm, okay, so WebGL demo. That is my game.js. Set up video. Add this to the end. Init, load shader, load texture. Is power of 2. So the video element is HTML, and we're using JavaScript to create it. These are event listeners. Yeah, I probably should put them on separate lines for readability purposes. Hmm. Okay. Yeah. So these variables are just named after the event listener. The event listeners are predefined by in the web browser JavaScript. It's just part of the code, but it's setting the variables. Okay, so we first set it up and then we load the video. It's automatically start playing it. Okay, so this is if everything is finished loading. So it'll constantly be running check up, check ready. So I'm gonna should I add a short circuit? Sure, why not? Doesn't really matter. All right, load init texture. Oh, what says replace the load texture, but I'm pretty sure I don't have a load texture. I have an init texture. So I have an init shader program. Load shader. Okay, load texture. Oh, okay. So it's telling me to replace this load texture with init texture. Hmm. All right. Let's see what the differences are. Init texture. Oh, okay. I guess we're no longer loading it because the texture is going to be a video. So it's not really changing it as much as it's just renaming the function. Yeah, ubit 00 to 55 text image 2D level internal format with height border source format source type pixel. Okay, yeah. So previously we were loading the image of the Firefox. I'm gonna keep this because for the game, this is probably what we need. We're not gonna be silly video. Hmm, interesting. I see that up here. Geo texture to the geo texture wrap S, clamp to edge, wrap T, clamp to edge, min filter linear. And then update texture. Oh, so this is interesting. Update texture. And texture is a video, so it'll be constantly up. Okay, let's see. Bind texture. Okay, so that's doing this stuff up here. Where for images, just does it here. Bind texture, 2D texture, text image, 2D level, internal format, source type. Oh, and then it used to be an image, now it's a video. And we are putting this in a function ooh, because we can run it constantly to update the video, because the video always is dynamic, always changing. That's what this is talking about. Video element. Yeah. All right, main function. Yeah, so previously it was calling load texture. Now we init texture and then we set up video. Let's see. Shader program, buffers. Okay, const texture. Yeah. Again, I'm gonna save this for later for video. Okay, init texture GL. It did not have the video form. Video. So init texture, I had load texture. Yeah, with the URL. I wonder. Let me just. Let me just. Let me be able to keep it. I want to keep it. Prevent the. Yes. Hmm. Okay. So by default, it's just a blue screen before the video loads. Oh no. I totally goofed. Ah, and it, yeah, I totally goofed. I started looking at the wrong one. Okay. I'm gonna download it. How big is this file? 8 megabytes. Gonna copy it over under images, public images, Firefox.mp4. Gonna have to change this accordingly. Okay. So we have the video downloaded in the directory that yeah, that it's not the same as in the tutorial, but I know from the previous tutorial that it should work. In your main, replace a render function with this. Okay, so render now. Now is 0.01. So that's the same. Draw scene. Okay, so add a hmm. Okay, video is that one. Draw scene, GL, program info, buffers, texture, key rotation, quest, render. Alright. Okay, let's check it out. See if it works. Issue. Okay. 87. Game. Line 87. Okay, and it. Okay. Yeah. Good comment. Get out. Cool. Nice. Got it. Got him. Pretty cool. Yeah. So that's the end of this WebGL tutorial. So now I have a grasp of what WebGL is all about. Now it's time to Google what I need for project. So first, WebGL. In this tutorial, it rendered squares and it rendered boxes. But now I want to render a cube. I mean, a sphere or a circle. So there we go. Uh, Let's make circles. Uh, so the basic building block is triangles, and we're just creating geometries from from triangles. Wow. So it's interesting. So it seems like the more wow, this is cool. The more the higher the resolution, the curvier we want the circle to be, the more triangles that will require. Let's make circles. We need triangles around the center, like slices of pie. So that will be interesting also because the center is clearly is defined. So when we want to move the circle around, we can grab the center, or we know where the center of the circle is. Once per pie slice. Drawing the circle. Ooh, wow. So it's using, yeah, it's using the WebGL function to draw a circle. That's pretty low level. Pretty low level, which is good, I suppose. Hmm. Let me try it. Yeah. Well, let's let's go down here. Okay, JavaScript. Yes. Yes. Okay. Hmm. So I'm thinking, you know, it's okay, yeah, yeah. So originally, so my thought was that if a circle is composed of slices of triangles, uh, and and if I want to load an image of a fruit, then is it gonna just like the fruit all these triangles? But in the tutorial before, each square is actually composed of two triangles, so you can see that there's no problem. It renders entire face is the rendered as the image. Vertex shader via source. Let me do a circle. Let me do a circle. I'm gonna try to use the same fragment shader. Well, maybe I shouldn't. Right. Let's just leave this alone. Yeah. Leave that alone. And then create a new one. Yeah, so I copied over the yeah, let's copy the vertex shader and the fragment shader and calling the function to emit them. Vertex shader, circle, vertex shader, vs circle, fragment, circle, fragment shader, fs, circle. And I'm gonna remove the lighting part. So sort of like going backwards. Yeah, I need the tutorial again. Before the lighting and texture. Yeah, let's see. Before the lighting, what was this? FS source. Frag color is just texture. Yeah. Use sampler. V texture chord. Yeah, so reverting back to without the lighting. Yes, okay, and then shader. Let me do the circle shader program. Init shader program. Init shader program. That should be fine. Yes, circle. FS circle. Okay. Same here. I do not need the. Let me revert the vertex circle. I don't need the normal. I don't need the normal matrix. And I don't need the lighting. So just the texture chord, geo position. Yeah, and then all this was added later. So it was just U projection matrix, U model matrix, U A vertex position, and texture chord. All right. So let's try it. Let's do circle. Let's see what's the difference. So for the vertex shader, attribute, float, vertex ID. So it be in float vertex ID. Okay, so it will allow you to specify the number of vertices, or will it? I don't know. V vertex chord. GL position. So num slices is 8. So we're going with 8 for each circle. I should also define as they have pi as radians. Interesting. Slice ID is for vertex ID 3.0. Okay. So one is getting the slice ID and one is getting the register. Hmm. So radius would also be interesting if we could specify that. Cosine, sine. So we have the center. Cosine. Okay, okay. And we have the angle. And then, yeah, so cosine, one gets the x, one gets the y. Well, cosine angle. So, I mean, it's the xy coordinate. Cosine angle is the x coordinate, sine angle is the y coordinate. And then radius is, the magnitude. So that places the one of the vertices right there. Position is y multiplied by the scale. So we got, and then z is 0, so that's the origin. And then 1 is, I'm assuming, the multiple circles. Interesting. Pretty cool. Pretty cool. Okay. So that was the blah 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 vertex. Now let's do the fragment shader. Precision medium float. I don't need the that. Okay. So I think I don't need that. Yeah. Doesn't say I do. So, oh wow. So it's calculating everything simply based on a number resolution. Don't need those either. Ooh, that's a very, very simple. No, I'm gonna need this because I don't want just a solid color. Yeah, and that's what that's setting it to. It's just setting it to a red. I do want this V texture chord. Ah, so I do need that V texture chord. Hmm. because it's math. Yep. So welcome back. Varying high P, varying in high P two in high P vec two retexture chord. And then I'm gonna have to also have this out high P vec two vector chord. This I don't know. I don't know. Vertex shader. I don't know. Yeah, I don't know how to get this V texture chord from this V texture chord and back to V texture chord is a XY. I'm gonna try pus because that's a XY. Okay. Create program. What? What? What is this? Create program from sources. Okay, traditionally, WebGL apps put geometry data in buffers and use attributes to pull vertex data from those buffers into shaders, convert them to clip space. It's important. It's only a tradition to do it. It's no way a requirement. How we do it only is that our vertex geo position. So main thing is that geo position is set, and that's what determines what shows up on the screen. Provide only a count as an attribute instead of positions. Oh wow. Circle of points based on that count. Hmm. Hmm. Yeah. There's nothing. WebGL utils. What is WebGL utils? Okay. Web. I mean, Uh, basically, or not, could be a bunch of, but it's not good enough. How do you make a sphere? Let's just start off with circles. Yeah, circle, not a sphere. Start off simple. Fastest way to draw many circles. Circle geometry. Quad. Cut out a circle in the fragment shader. Ooh, this is interesting. So it's creating a square and then cutting out the circle using math. How you're drawing. Wow, that's pretty cool. How you're drawing the circles, 2D, 3D, blending them. Less triangles is faster than more. Less pixels is faster than more. This is pretty. I mean, I think it's pretty cool. Let's see if I can. I mean, it's bogging down my laptop, making scrolling lag. Let's tune this down a bit. Yeah, yeah. Let's not go crazy. Hmm. You're killing me. You are killing my system. 60. All right. Awesome. Is that the max? Okay, great, 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 great. Okay. Now let's go through this article. Mm, okay. So what is this doing? So VS, vertex shader, geo position, and then we get the coordinate and the color. Huh. Oh, I see. Because it's generating the color. Position. Fragment shader. We get the coordinate and the color. Create program info. Yeah, TWGL. It's handling most of the stuff. But you know what? Just try it. Let's just try. Let's just draw textured quads with no blending. Repeated geometry and instancing. Text area. Computing. Going in. circle function. This card is slower. Hmm. A, B, C. So let's see. We got float ID and float vert, which is flow ID and back for position and back to text core uniform float time minus time. Let's not do time. A texture chord, text shader. What is this doing? Texture quads. No, 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 no. That's not the one that he says later on. Position text chord. All right, had enough of this. So this here, the vertices, the order is different. Wow, this is cool. GL triangle fan. That's what they were talking about. And the answer. Okay, draw arrays. GL dot draw arrays. Let me see. Where do I have GL dot draw arrays? Hmm, I don't have that. Okay, draw elements, triangles. Okay, so this is under draw theme. Okay, nice. So offset, I can still do 0. Vertex count, I can still do 36. Hmm. Okay, so 36. And we get this line. Vertex count from 4 to 101. Program info. Yeah. So it seems that main. No, not main. Wait, it is main. Main? Okay, okay. So after it does the program info, then it finally calls draw scene here. So if I want to change that, add it. Circle program info. Yeah. Circle program info. See, const program info. Const circle program info. Program, not shader program, circle shader. Circle shader program. Attrib locations. How am I ever gonna get this? Okay, so it's calling. Okay, calling calling them, getting them from the shader program. I don't need the normal. Vertex position, texture chord. Yes, that works. Init buffers. Hmm. So back to the vertex, the shaders. Circle, in, float ID, position. GL.draw triangle fan. That was in draw scene. Draw scene. Draw scene will also now take circle. So, and because of that, now I can program info. I wonder if this is going to be an issue. Circle program info. And then I'm also going to use Circle program info. Circle program info doesn't have a normal attribute. I think. Double check. Circle program info. Yeah, no. I don't need a normal matrix. Draw scene program, circle program info. So I got this circle program info. Use uniform. Don't need normal again. Other two are okay. Texture. Um, Draw elements. Ooh. Ooh. This might not work. This might not work at all. Yeah, I don't think it's gonna work. Draw scene. I need to draw circle. So let's see, draw scene, draw circle. Okay, let's undo this. Draw scene stuff. The stuff that I copied over. Yes, all the stuff with the circle program info. Yeah, circle program info. Yeah. So draw scene should only draw that stuff. Draw circle. Clear color. Clear depth. Clear color. Clear depth. I wonder if it's gonna clobber each other. So program info is now a circle program info for draw circle. Uniform locations, use sampler. There we go. Hmm. Vertex. He used 101. Maybe I should too. 36. 128. How about 64? And we're done. And we're draw circle. Projection. Translate. Set position attribute. Set position attribute. Let's do set circle. Position attribute. Set circle. Texture attribute. And then let's set position attribute. See what they got here. Some components. Set normal. Set color. Set texture. Well, maybe I could. Yeah, why not reuse the same methods? So these are totally new. Oh, they need to be separate buffers too. Otherwise, they could clobber each other. Hmm. Buffers. Yeah. I wonder how does that work when I have multiple objects. Buffers. What is buffers? What are buffers doing? And the position, color, texture, all of these color buffers, color buffer, texture buffer, texture coordinates, XY, 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 XY. Hmm. Okay. Init shader program. So all this buffer stuff looks okay to me. Buffer stuff, okay. Draw scene. Where is it doing the shader stuff? Use program. Find buffers. Find buffer. Draw circle. Alright. Init shader program. And it has to be here. Okay. So circle vertex shader. Still some questions about this. Oh, init shader program. Okay. 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 That might be okay. Yeah. Texture. Init texture. I don't think it's gonna work, but let's just try. Vertex ID undeclared. Pi undeclared. That would be in the other file. Vertex ID, and it's in the shaders. So vertex ID. Yeah. Yeah. Yeah, I just want a simple shader, vertex shader for circle. Circle. All right. What's the source? What's the sauce? Give me the sauce. RGB. Program. Hot 2.0. Okay. So that's X. Oh wow. This is one simple program. Use program. Prog. Alright. Rotation radian. What? Okay. So this drew lines, draw rays, lines. 0. So that's the origin. We can pass in anything. See, what am I passing? What am I passing in for draw circle? offset 0. So I'm also passing in 0, offset 0, and then divide by 3. Rotation radian. Rotation radian. Okay, attribute set floats. I'm sorry. I don't. A square circle. Come on. Why is it making it so complicated? Will this do it? Will this do it? It's broken code. It was very simple. Draw circle is not defined at render. Game 140. Render now. Draw circle is not defined. 140. Oh, that's because I never exported it. And then I should also import it. Yeah, too many errors. 287. Well, this is a big fail. But yeah, it is getting late. So therefore, I think I'm gonna end it here. And next time, let's pick it up and figure out how to render a circle in WebGL. Thanks everyone for watching. Sorry we ended on a bad note, but anyway.